class with yesterday. There were two things that I told you that I wanted to see. First of all, I wanted to know how we know that there are going to be two linearly independent solutions, and I want to know where they converge, and then you had to find them. So the first thing to find is to find those singular points. Singular points are at plus or minus I. X equals 0 is an ordinary point. That tells us we're going to have two linearly independent power solutions. Okay, I think we got the converging wrong. So there exist two linearly independent power series solutions of this form, so x being 0. They converge for at least the absolute value of x minus 0 is less than r. R is the distance from our ordinary point to the nearest singular point. So a lot of you saw I and made that infinity because you said, well, I can't find the distance between 0 and an imaginary number. That is not true. Right. It's like finding the norm. So you find the norm of the complex number, that'll be the distance. So it's really 1. It's not going to get more complicated than that. We're always going to use x equals 0. So in the case where you have a singular point that is imaginary, find the norm. And that will be the distance you use. Okay. So here's what I did. Differential equation, plug in your y double prime, y prime, your y. Distribute the x squared plus 1. Don't make this in standard form. So what a lot of you did is you divided by x squared plus 1 and they got stuck. You don't have to do that. Distribute x squared, which changes that power. Distribute the 1, put the x in. Then we looked at what everything starts with. We need everything to start with x squared. You pull 2 terms out of here, 1 out of there, 2 out of there. What a lot of you saw is those C1x's cancel. Okay, starts with n equals 2, n equals 2, n equals 2. Those are all good. This is the only one that you need to change. Did that go okay so far? Okay. So then, okay, this together equals 0. That does not mean that every single term equals 0. The x term equals 0, so that tells us C3 is 0. The constant term equals 0. That tells us that C2 is 1/2 C0. Okay, so set the constant equal to 0, so you get C2 in terms of C0. 6C3 equals 0, so C3 equals 0. Here is the single summation, which you're going to set equal to 0. You're going to have to combine like terms, factor, and your recurrence relation will look like either of those. Okay. Can I keep moving? Okay. This is what I ended up with then. So I did the first few terms. There are a multitude of ways that I would accept your answer. So what I did in red is I tried to find a pattern so that I would be able to write a summation in my answer. You don't have to do that if it's complicated. So this is pretty complicated. I don't expect you to be able to come up with that summation. This is one answer then that has all the C0s together. There's only one term that has C1, so that is your second answer. Okay, besides in red, the other way that I would accept your answer is if you put y1x equals factoring out the C0, and you just have 1 plus 1/2 x squared plus -1, 4 times 2 is 8, x to the 4th. So I will also accept your answers if you just write out the first few terms. And then y2 is just C1x. So either write out the first few terms, or if you can write it as a single summation, you can. On your test, I will tell you right now, I am not going to require you to come up with a single summation. So you just write your first few terms, and that's what I will take. Okay. This should be pretty similar to what you guys did last week on Friday.